Just FYI, if you keep track of things like this, you probably could have deduced this on your own, but that took a while, man. I made that unit. I just freestyle a lot. Like that could have been probably a 6-week unit, and I turned it into a 12er. So it's all good. Like I'm gonna get us to the finish line, trust me. But that unit took a long time. So this marks the beginning of unit 2. I'll make sure unit 2 doesn't take 12 weeks. This one should take a few, at worst, a few. So Thanksgiving break kind of makes it feel like it'll be longer, but when all said and done, it'll probably be like 12 school days or so. So something like that. Anyways, unit 2, we're into unit 2. So today, to start the second unit, you are going to learn about absolute value equations. And honestly, if you are titling the unit, which is interesting, but it's all good, unit 2 is actually just about absolute value equations and inequalities. Yeah. So I say it's not a very long unit because we'll spend a couple days on equations, and then we'll spend a lot more than a couple days on inequalities. And then that's honestly, I haven't looked at the district assessment to like really wrap it up, but that's going to be the meat and potatoes of it, is just like 2 big topics. So today and tomorrow, or not tomorrow, but like Monday will be absolute value equations days, just equations, no greater than signs, no less than signs, just equal signs. So let's get to it. So here is an absolute value equation. And it's been a while probably since you've seen those absolute value bars. I can just give you some pro tips. And this is especially handy for those of you with garbage handwriting. Make sure your absolute value bars are taller than a normal number 1, because they start to look like ones. So you'll notice like anyone who's paying attention can clearly see that that's not 1x1, right? That's like the absolute value of x equals 8. And do you guys remember what the absolute value of a number means? Mm-hmm. Yeah, it was a good team effort, but the bailout came in strong, right? That's it. Concise, clear, simple. I'm saying to you that to solve this equation, if I'm going to be X and I'm going to say, I have solved your equation for you, I am going to be a number that is exactly 8 steps away from 0 on the number line. And if you understand your number line, you understand that 0 is right in the center. How many numbers are there that can say, I'm 8 steps away from 0? There are 2. And their names are X equals -8 and X equals +8. I will caution you right now, and I'm going to write this in red. So don't do what I'm about to do in red. And you'll see why in about 2 minutes. It'll be obvious. But do not write something like X equals -8, 8. Under normal circumstances, that would fly just fine. But again, for reasons you'll soon see, don't do that. So when you state your solutions, you need to state them out separated as X equals this, space, X equals this. And I'm, again, I would never micromanage you for just weird reasons. Trust me on this one. Okay. Yes. Not even close. No. So again, to be very clear, you need to write 2 completely separated equations. And you'll see right now in the next example why that is. Got it? So when we solve a simple absolute value equation like this, that's it. 1 step, I'm done. And that 1 step was to take that 1 equation and acknowledge that it actually can be stated as 2 separate equations. Notice that my purple equations do not have the absolute value on them anymore. That's important. Right? I'm not talking about absolute value once I get to the purple. I'm saying that to solve your equation, X could be this or X could be this. All right, so let's take a look at the next one. This time we're going to say that the absolute value of some number -9 has to equal 3. So the next like 30 seconds, how well you listen the next 30 seconds will really dictate how well this assignment and this part of the quiz/assessment will go for you. So here it goes. If I took my pen and I did that, and pretend you didn't know what was under my yellow vandalism. Because like if you were just looking at it, Mr. Manlove walked in, he'd be like, I don't know what's under there. He could only tell me a little bit of information about what's under there. What could he tell me? What does what's under there have to be? It could be 3. What else could it be? It could also be -3. So you're really missing the boat. Don't be silly now. Listen carefully. If you missed it, that's okay. Let's not dwell. Let's get this right. What's under the yellow either has to equal 3 or it has to equal -3. Do you agree? So having said that, then I'm going to take off my yellow vandalism, and I'm now going to do what we will come to lovingly and very commonly refer to as the split. And when you split an absolute value equation, you make 2 separate statements that both have to be true. Statement number 1 is this: whatever's inside the absolute value, maybe it equals 3, right? We agree. Or on the other hand, maybe whatever's inside the absolute value equals -3. And so what we've done is we've actually split the absolute value situation into 2 normal little 7th grade equations that we can now easily handle. By handling those 2 purple equations, just the regular non-absolute value equations, we're going to find the 2 numbers that if we put them back up in here where the red arrow's at, they would both be true. And we'll see that. So if you solve this little baby equation on the left, you of course get x equals 12. And if you solve the little baby equation on the right, you of course get x equals 6, right? Add 12 to, or add 9 to both sides. So take a look for yourself. Go up to the red arrow and put 12 there. What's 12 minus 9? Mission accomplished. The absolute value of 3 is 3. And then take the 6 and put it up in there. What's 6 minus 9? And the absolute value of -3 is 3. That example right there, if you understand that, will really, like I said, completely just dictate almost primarily how well you do on this section. No stubbornness here. Notice when you split and you go from absolute value down to regular equations, you must take off the absolute value bars or it just doesn't make sense. Clear? All right, let's go again. Round 3. So no cool guy points for like looking at this and solving it in your head. Like a lot of you could do that, and I'm not interested in that. What we're practicing right now is the repetitive action of splitting an absolute value statement into 2 non-absolute value statements. So what's one of my equations that has to be true?
4 equals 95.
Yeah, so maybe the stuff inside the absolute value equals 4, right? Or maybe the stuff inside of the absolute value equals correct. One of those statements has to be true, right? I mean, they both work. They're both facts. So on both of these equations, if we multiply by 3, we're going to get on this one m equals 12. And then on this one, we're going to get m equals -12. So you already see why the answer to the question, like on that first example 5 minutes ago, why can't we write it this way? Well, this is why. Because we're not trying to just compact it. We're trying to literally write 2 separated equations. That's the goal. So any questions so far? Okay. Example 4, I don't have a ton. I think I have like 5 more. And once you got the flow, they're going to just keep rolling. So for this one, we have the absolute value of 3x minus 11 equals 4. I don't know what x is. All I know right now is this. The stuff that I call it, sometimes I call it the cream filling. The cream filling, it's like a cookie. So you got your cookies, and then you got the cream filling in the middle. I don't know anything about x, but I know this, that the stuff in the middle might equal 4. I also know that the stuff in the middle might equal -4. Those are both potential facts. Well, they're both facts. And then again, if you struggle with an equation like this, you're probably not in the right class anymore, right? Like, so we got to add 11 to both sides. We get 3x equals 15 divided by 3. One of my solutions is x equals 5. And then the second equation, if you add 11, 3x equals 7. Divide by 3, you get x equals 7/3. Start getting used to seeing fractions. You're going to see a lot of them. It's totally normal. Okay. You're going to get weird answers like 29 over 7, -5 over 3, stuff like that. Totally normal. And it's interesting. I mean, it's not, you won't think it's that interesting, but it's kind of fun every once in a while to just keep yourself in check and go back and actually put your solutions in and watch it happen. You can always, this is like factoring. You can always grade your own paper. It's so cool. So like if I put 5 where that red arrow is, what's 3 times 5? 15 minus 11. Beautiful. And this one might be a little harder for those of you with shoddy skill sets, but if you put 7/3 where the arrow's at, think about it. What's 3 times 7/3? 7. What's 7 minus 11? -4. Whose absolute value is? Jackpot. Good. I'm going to skip an example. Just because I don't, my spidey sense is telling me we don't need that one. So I'm going to put this one here. Quite frankly, we probably don't even need this one, but we're going to give it a go. This question will come up for a select percentage of students. So let's get this out of the way. Step 1 is the split, right? What will my first split equation say? Sure, that's a possibility. What's my other split? Good. And I just thought, you know, because someone's going to ask about this, like it's a little bit odd because the x has a negative on it, right? So since you're not like in 7th grade, I'll just teach you, this is how I solve equations like this in my head. I just take the x and move it over like this because that makes them positive, right? And then I just, to exchange, I then take the 5s and move them back over. So it's a real quick mental math way to solve equations. So what would the first one be? X equals what? How about the second one? Good. So you're at a point in your math career now where solving little things like that, you don't have to show work, you know. When we do these on a quiz, the demand from me will be like non-negotiable. These always get written down. Always. Untouched. Split, split, and then how quick you go from there is kind of your business. All right. All right, we're going to change it up a little bit now. Yeah, you would. And I don't think that, you know, as your algebra teacher, I don't feel like I've ever asked you to solve this particular type of equation before. I think that's pretty accurate. But your instincts kick in and you say something like Kinsley just said, and you probably don't even need me sitting up here telling you this, but your instincts are strong by this point, right? And you know that things are out of place. And you also know that the 6 should be the first one to go. You're already kind of honed in on this idea that I really want to get to the point where I can split it, but I can't split it yet because I don't have the absolute value by itself. That's, you remember like when we did our factoring unit, how GCF kind of became the battle cry? Your battle cry now for the next couple of weeks is get the absolute value by itself. Okay, that becomes the thing. So let's do what Kinsley said. Let's get that 6 and vote him off the island. So that leaves the 2 and the absolute value of x minus 9, we're closer, equal to what? 14. I got to subtract it to the other side. And then we're going to do what? We're going to divide both sides by 2, right? So we're on a mission here to say, can I get this thing by itself? The absolute value chunk. We're not tinkering inside. You don't dare touch that 9. He is off. He is in prison. Right? No touching stuff inside until you splitsville. Once you split, open season. So if I divide both sides by 2, I get to exactly where I want to be. And I get the absolute value of blah, blah, blah equals 7. And it's at this point that you now are required to go whoop, split. What's the first equation going to say? Second one? Just like that. Again, I don't expect you at this point to show me +9 on both sides. You're certainly welcome to. You get down with your bad self. But what is x on the first one? Second one? Done. And it's always, again, for me, because I'm a dork, it's kind of fun or validating to go back to the beginning and put the numbers in. Like if you put 16 right here where the red arrow is, it's kind of fun. What's 16 minus 9? 7. The absolute value of 7 is 7. 2 times 7 is 6 plus 14 is neat. Yeah, what he said. This will be our last example. You don't need any more than this. So last one. Let's do 7 equals 12 minus the absolute value of 3x plus 5. And at this point, just FYI, if you haven't figured this out already, really inside the absolute value, you could just kind of write IDC, right? Like we're not interested right now in what that says. We're basically just toting all that stuff around like a brick until we can split it, and then everyone's free to move about the cabin. So what do we do first? You would subtract 12, and that on the left-hand side gives us what? Careful how you say that. 5 equals what? Much better. Good. So I've seen in the past where people get to this point and they think it's time to split. You guys are too good. You know better. You didn't fall for it. Like, you know that negative is just like a -1. He's got to go just like anything else. And so at this point, it's time for Splitsville. So we have one of our equations says cream filling, maybe u equal 5. Or cream filling, maybe u equal -5. Don't know. But they both work. So on the first one, subtract 5, you get 0, right? Divide 0 by 3, you get interesting. So one of our solutions is 0. That's okay. It's nothing weird, just a number. And then on the other one, if I subtract 5, I get 3x equals -10. And if I divide -10 by 3, I get -10/3. The last thing I want to say before I quit the recording and let you get to work, and hear me on this one, this is not going to happen to you today. I clicked like 50 times through the assignment, and of course, I say this, I don't think this is going to happen. But before you pack up your notes, consider this. What are the solutions to this equation? Nope. Say what? Finish your sentence. Correct. In absolute value, if I've passed my threshold, the scientists say that you get 20 minutes with humans and then they stop listening. If I'm past that, I need you back. You cannot solve an absolute value equation that states something like this. Sutter, you nailed it. Absolute value, by definition, is like a machine. This red machine up here on the TV, hear me now, this is important. He will never produce a negative product. You could churn him out for a month, a year, 1,000 human lifetimes and keep working that absolute value. And he's like, I'm sorry, I am incapable of giving you back a negative answer. The lowest I can give you is 0. But by definition, I will always give you a positive number or a 0. Therefore, an equation like this has simply no solution. And that concept, that idea of absolute value never coming out negative is going to start to play a really pivotal role, just not today. Got it? Good. All right, your assignment's on the old Daddy Delta math. Goes without saying, but here I go saying it. You really should use paper and pencil. It's a good idea. I'm still recording. Why do you ask? Get what? Oh, Bryce Humphrey started calling last year a bunch of weirdos in that. What was that? Third hour last year. Bryce started calling it Daddy Delt. So yeah, don't ask. I didn't come up with it. Who had a hand over here? Yeah.
It's negative, or is it because it's at?
because it's negative. If you get to the end, before I finish the recording, if you had a problem like this, if you had like 5 minus 2 times the absolute value of blah, 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 blah equals 11. So if you went through the normal motions on this problem, and you would of course subtract 5, right? So you would have negative 2 times the absolute value. I'll just put something in here. Let's do like m minus 4, because I don't care what it is. Equals 11 minus 5 is 6, right? What would you do next? Right. And when you divide both sides by negative 2, something bad or interesting happens. You get the absolute value of m minus 4 equals negative 3. This is an impossible statement.
Okay.
You could spend 1 trillion human full lifetimes doing nothing all day, but trying to find a number, you could never find it. So that has no solution.
So when the answer is negative.
Right. But that's only true if you've got the absolute value by itself. Do you understand that?
Yeah.
Okay. Yeah. I'm going to pause instead of stop the recording, because someone might come up with a problem and be like, hey, this was not in the lecture. So I'll just keep it paused. If you have a question, just let me know.